So we're going to be looking at two more example problems to find the area of regular polygons. But now we're going to be even given less information. And so these two problems are going to involve us using some trig. So here I still want to find the area, and the only thing I'm given is that my radius here is 4. And I know this is my radius because the segment's going from the center to one of the vertices of my polygon here. So I'm going to first figure out how many sides I have. So I'm just going to count up. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have n equals 9. I now want to use 1/2 a times n times s. So I still need to figure out what my a is, my apothem, and what my side length is. And so, again, looking at this, I can create a right triangle from this radius by drawing my apothem. And so I can draw my apothem here, and I get this triangle. And so I'm going to redraw this triangle right here. So if I look at this right triangle that I have, I don't know what my apothem is, so I'm just going to write A. I don't know what my side length is, so I'm going to write B. But I do know my radius, or my hypotenuse in this case, is 4. And now something else that we learned in our last lesson was something called the central angle. And so if I were to draw another radius right here, which I know is also side length 4, I can find my central angle, this whole entire angle right here. And we find that by doing 360, here, I'm going to stick with purple, I'm going to do 360 divided by the number of sides, which here is 9. And I get 40. So I know this whole angle is 40. However, we also learned that the apothem bisects my central angle. So that means that both of these angles here are going to be the same. And so I can figure out this angle measure right here by doing 40 divided by 2, and I get 20 degrees. And so that's going to be, this angle right here is 20 degrees. Now this becomes a trig problem where we can find a and b using our trig. So let's first find what our apothem is, a. Well, going from my given angle 20 degrees, I see that a is my adjacent and 4 is my hypotenuse. And so thinking of SOHCAHTOA, the one that has adjacent hypotenuse is going to be cosine. And so this becomes cosine of 20 is equal to my adjacent over my hypotenuse, so a over 4. And so solving for a, I can just multiply 4 on both sides, and I get that a is equal to 4 cosine of 20. Now b, I see, is opposite of my 20 degrees. And so I'm going to have opposite in hypotenuse, which is so. So this is going to be sine. So I have sine of 20. So I'm going to be my opposite, which is b, over my hypotenuse, which is 4. And so solving that one for b, I also get that b is equal to 4 sine of 20. So I have that this part is 4 sine of 20. So that means this other half is also 4 sine of 20. So that means that s is just going to be twice b, which is equal to 8 sine of 20. So I have my n, I have my a, I have my s. I now can plug those in to find my area. So area is going to equal to 1/2 a, which is 4 cosine of 20, times n, which is 9, times s, which is 8 sine of 20. And I can plug all of this in over in Desmos. So coming over here, first thing, make sure that you are in degree mode. So you're gonna have to hit that wrench here, switch to degrees. And so I'm gonna type in 1/2 times 4 cosine of 20. So 4 cosine of 20 times 9 times 8 sine of 20. And I get 46.3. Okay, let's try one last one. This time we are actually given the side length here. So this time I have that my side length is 7. So I have that s is equal to 7. Counting up the sides, I see that n is equal to 6. So this one, the only thing I need is my apothem. And so I want to go ahead and draw that in. So I have my center here. Draw my apothem. And my radius. And so I have this right triangle right here. I know this entire side length is 7. I know this apothem is cutting this side length in half. So that means that this bottom portion is just going to be half of 7, which is 3.5. And so I have this right triangle right here, where this is 3.5. I don't know my apothem, so I'm just going to write A. And now again, we need to figure out what this angle measure is right here, like we did before. And so now if I were to draw another angle, I know these two angles are the same. So I need to first find my central angle, and then I'm going to divide that in half. So I remember from before that my central angle is just 360 divided by the number of sides, which here is 6. And so I get that that is 60 degrees. And so to find out what this angle measure is right here, I just need to do 60 divided by 2, and I get 30 degrees. And now I can go ahead and use some trig. And so I see, compared to this 30 degrees, my A is adjacent to it. My 3.5 is opposite of it. And so thinking of SOHCAHTOA, that means that this is going to be TOA. It's going to be tangent is equal to opposite over adjacent. And so I have tangent of 30 is equal to opposite 3.5 over adjacent A. And so solving this for A, you can do cross multiplication and you get A tangent of 30 is equal to 3.5, and then divide both sides by tangent of 30. And you get that A is equal to 3.5 divided by a tangent of 30. So I have my S, I have my N, I have my A. I now can figure out what my area is. So I have 1/2 times A, which is 3.5 over a tangent of 30, times N, which is 6, times S, which is 7. And so I can go over to Desmos again. So I have 1/2 times 3.5 divided by tangent of 30 times 6 times 7. And I get rounding to the nearest tenth, 127.3.